welcome back to
2019.
Are we good to go?
Yeah.
Welcome back to Leeds Sharp. Happy New Year. It's now officially definitely too late to say Happy New Year. Has anyone done the dry January? No?
What's that?
A moist one maybe? No? Okay, good.
What about the other January?
The what?
The other January.
What's that?
Come on. Peak January.
Oh.
Really? I never heard that.
Keep over.
There you go. That could be our newest. Alright, okay, so we've got a quattro formaggio of talks.
Four to it's five.
No, it's four because there was a bit of a mix up with the MVP with the
Okay. Four talks.
Martin Beery.
4 lightning talks.
Yeah. Did you want to say some news?
We could do a little bit of .NET news. Do you have the news?
I have 5 on my list, not including Martin.
Well, we'll see. There are 4 or 5 talks. By the end of it, we will know.
I kind of need to know what we're doing.
Alright, extra topping then. Extra topping.
Visual Studio 2019 Preview 2 has been released. I've been playing about with it. Seems fairly nice. Sort of some incremental stuff, but nothing that amazing. The menu bar takes up less space, so you have more space of code. It's quite nice. It's got quite a nice thing, which I've not used as much as I thought I would, where you can, when you're doing a watch of a certain variable and it's got an array containing an array, you can do a search and it will search for stuff inside there, so you don't have to go item 1, no, item 2, no. That's quite nice, but I don't use it as much as I thought I would. So, worth checking out. It seems to be fairly stable. And I think someone was telling me .NET Core Preview 3, Preview something has been released. Was that?
Preview 2.
Preview 2 of .NET Core 3. Any good? Yeah. Isn't that sort of...
yeah, if you like WinForms,
it's WinForms sort of stuff in there. So,
Yeah, that's cross-platform with WPF and WinForms on Linux.
That is quite exciting.
Natively
Well,
designed WPF and
you've always been able to do WinForms on Linux, it's just been sort of not advertised well. If you use Mono, it cross-compiles to GTK Sharp. So, pro tip.
So that's... Okay, there. So it seems quite cool. Does that work on Macs as well then?
Yeah,
That is about time. So very exciting one. Any more .NET news anyone's aware of? No more .NET news. Okay, that's the
Cool,
.NET
let's
news
kick
section
off.
done.
Kick off with the first talk, MassTransit.
By the lovely Kevin.
By Kiran, yeah.
So cool. So this talk's on MassTransit. I don't know. Put your hands up if you used MassTransit before. Cool. One person. I can just completely bluff everything. So that's some useful information about me. Probably useless information about me. Mostly C# and JavaScript based something really. So skipping that, MassTransit is like so on the website it says it's a free open source lightweight message bus for creating and distributed applications using .NET framework. And when you go to people and tell them that, it's kind of a bit of a mouthful, and it doesn't really explain kind of what it does. So I kind of like think of it about it as like the web API for messaging. So if you kind of look how like web API works, who's used web API really, by the way? Yeah, pretty much most people. So you kind of have a HTTP client, and that a lot of people might be able to see. You have a get async and a post async as T, so you can pass any kind of .NET type to it, and you can do a read async of T as well, so you can get any type back from it. So it does the bits and bobs under the hood for you. And then we have an API control on the server side, and that kind of does the rest of the stuff for you. And then you at both sides you're just dealing with like .NET models, so you don't need to care about kind of the underlying transportation. And we can send a request to the server and get a response back from the server, and then there's just a lot of magic in between. And a lot of magic in between is it's all based on the HTTP listener, routing, serialization, model binding, model validation, content negotiation. So it's doing loads of stuff underneath the hood for you, but you get to just interact later with it with like just normal C# code really. So as I said, like web API, MassTransit is like a web API for messaging, and if you put that into MassTransit's perspective, we kind of have the similar kind of things underneath. So we have on our sender side a send and a publish of T, so we can do bus.send of a given type, and a publisher of a given type as well. And then on our server side, we can just have a consumer T. So if you want to get a certain thing we're passing back, maybe like a person object from sending it to the server, we can just subscribe to like a T person. And then the magic in between kind of deals with all the managing your connections, your routing convention, how the topology works, and all the serialization. So it might be JSON, BSON, XML, or encrypted. It does all the logging for you as well, and does a lot of fault handling as well for you. So that kind of like sums it up as a very kind of brief overview. But that kind of is underpinned by a lot of different message brokers. One of them is one of the main ones is RabbitMQ, but it also supports Azure Service Bus, ActiveMQ, and SQS. So if you're using any of them, it just wraps them all them up as well. So this is kind of what an API controller looks like. So you'll probably be familiar with this. You get the you have a controller which inherits from API controller. You do a post with the request in it, and you get a response back out of it. And you don't really care about how that's getting serialized over the wire. It just kind of works. And the same thing when you try to talk to it, you get the post as JSON, you pass whatever you want to pass into it, and then you can just read it back as whatever you want to read it back as. And then you just model your classes as just POCO objects. And if you look at MassTransit, it's very similar. So we have a POCO object that usually use interfaces for these. And this is because we can use polymorphic routing on top of it. But I'm not going to really go into that.
Paramotic routing?
Polymorphic.
Oh, polymorphic, sorry.
Yeah. And then for our kind of like API controller kind of thing, we have like an iConsumer, what you heard it from. And for this one, we've got an order request consumer. And that just means we pass in this order, this consume context, which actually has an iOrder request in it. And then we could just deal with the objective, which is a message, and we got all the properties like in our web API. And then we can just pass back a new iOrder accepted as an object as well. And then to talk to that, we can just use a bus.publish and just publish our type to it, and then we don't really care after that point. So that's kind of like, you don't really need to care about the underlying like message platform and how it's serialized and deserializing things. It's just kind of magically done for you. And so MassTransit also provides a lot of like kind of features on top of that, of just kind of communication over the wire, and I'm going to go into a few of them as well. So the first one is concurrency. So you can limit the amount of concurrency you've got through one kind of queue. So you can say, I don't want to like get one messages every given one time, or I want a consumer of like order accepted, so they can just pull one off this time, or you can pull 5 off or 10 off, and you can just deal with concurrency of them messages. It also deals with connection management. So if you've got like it's a network where you keep disconnecting, it batches things up, and they can push them to the back to the message brokers afterwards, or actually just keep polling it to see if there's any more messages coming down. So if you get a disconnect, it'll always reconnect. It also wraps up exceptions. So if you get an exception in the system, it'll automatically move that to an error queue, and then it can be replayed later, or you can deal with that however you want. And you can also apply retries to logic to that, so you can exponentially back off if something's going ropey in the system as well. It handles, you can handle things with circuit breakers. So this is where you kind of, if you've got like an API down, it's giving you 500 back. You can limit it to only push one out every minute until it gives you a 200 OK, and then it can just like fire the rest into that API. Or you can then apply rate limit to that. So you might not want to throw all 500 at once. If you've got them all batched up to the API, you might want to rate limit that to say you only want to put 10 in at any given one time. So you're not just DDoSing their API. Also, it does partitioning. So if you've got like a big massive file with like loads of orders, what you need to process, you can take that file in, split it apart, and then you can get you can split the cluster up into different partitions. So say you want orders 1 to 10 being processed with one service, and 11 to 20 with another service. You can kind of split up so it processes things a lot faster. Serialization. So by default, it's all in JSON, but you can use XML, BSON, YAML if you really want to. It also has some encrypted serialization, which is based on BSON as well. But you get the main one is JSON, but you don't really need to care about that. It kind of just deals with it itself. And you only do it on the publisher's side. So whatever you publish, it'll have the content type and the payload, exactly the same as like in Web API. And then the consuming side will notice that payload and it'll be like, this is the content type of JSON, so I'm going to deserialize it as JSON. Or if it's XML, I'll just deserialize it as XML and just deal with it. One of the main things when dealing with message platforms is kind of correlating things together. So if you've got like a lot of logs and you've got loads of things in different parts of the system, all distributed, you need a way to correlate these kind of messages flowing around your system and how they originated. So by default, MassTransit adds message ID headers. One is just message ID, which is just a unique ID for that given one message. So then you can say how many times that message is being retried, replayed, moved to an error queue. You can see where that message has progressed. You also get conversation IDs, and these are other messages what have come off that one message. So you might have like 3 messages published from one message, but that'll turn into a conversation. And then you also get correlation ones for doing like sagas and things like that, when you listen to things going backwards and forwards, so you can correlate them back together. It also deals with lifetime management. So all the stuff that you create inside your consumer, it'll just dispose of it for you automatically. So obviously this is underpinned by an IOC container. I think they use AutoFact, but you can swap it out if you want to. But that just deals with all the kind of life cycle of the kind of each consumer, so it cleans up after yourself. As I said, it deals with routing topology. So it's got 2 built into it where you can choose, but you can also make up your own if you really want to. But usually the defaults usually magically work anyway. You don't really need to care. It deals with sagas as well. So if you've got like long-running processes, what need to listen for things coming in, so or time-based events, you can use sagas for them, and that's all underpinned by another open source project called Autonomous, which is written by the same guys as well. It's pretty cool, and it's very kind of easy to read how it's been kind of broken down in that language for it. It's got scheduling built in, and this is built on top of Quartz. So if you've ever used Quartz before, you don't really need to know Quartz, but it just kind of magically works on top of Quartz. So if you want to reoccurring like messages or rescheduling messages to publish at like 3 AM in the morning, you can just do that as well. So that's kind of it for that kind of the slides kind of thing. There's a really fast overview. I've got like 5 minutes left. So I'm just going to give you a little demo of some code and kind of how it interacts and show you around the code really. So we're going to start off with a shop demo, and we're going to have 3 console applications running. So we've got a shop service, as to say, and that'll be taking orders. We've got a payment service, which will be just taking payments, and some of the payments might fail as well in this scenario. And we also have a reporting service, so we want to be able to see which payments failed and how much of that money we've actually not taken. And it's all going to be in the reporting service. And the reporting service is just going to use a mocked out database in memory, but you could use whatever you want really. And then also we're going to use MassTransit in the middle of all this stuff, and then it's going to be underpinned by RabbitMQ. So these are the scenarios we're going to cover. So we're going to build an order from inside the shop, and then we're going to send an order requested message off onto MassTransit. MassTransit will then forward the order request messages onto the payment service and the reporting service. The payment will succeed. That will report back saying the order's been accepted because the payment's been taken, and then then the reporting service will subscribe to that and know that is actually being succeeded. And then also we'll be able to query the reporting service to see kind of what's been how much money's been taken. And also if we get an order request service message into the payment service, that might fail, and then that'll return a fault. That fault again go back to the shop, so that shop can say we failed your payment, can you retry? But it won't update the actual reporting service. So I'll quickly show an example of that, which will hopefully work. So to start off with, you need Rabbit. So can everybody see these pulling out? They're really small. It's all run on Mac OS as well, which is great. Dotnet core. So that's started. I should show you that first. So I've just started RabbitMQ inside Docker, which is nothing fancy. It's pretty much Docker run. But that means we can go to here and look at it. So can everybody see this? So we've got no queues, no exchanges, pretty much nothing there. It's just like a brand new instance of RabbitMQ. But then if we start starting our services up, so we'll start our shop up and our payment service and then our reporting service. So these are just all started up. So I'll show you these. So this is our shop. Can everybody see that? It says, welcome to the shop. What do you want to buy? Some bread, milk, rice, pasta, some cereals, chocolate, some pies and sandwiches. And then we've got a payment service over here, and we also have a reporting service over here. And the reporting service at the moment, if you say, give me the report of what's been bought, it'll say there's been no sales. But then if we go back over to RabbitMQ, you'll see that it's created loads of these exchanges. So we've got like an I order accepted, an I order requested. And if you click into these, we'll be able to see the bindings for these. And it says they go into payment and reporting queues. And then there's some stuff off the back of them, what's actually going to be consumed from them, which is then the services. So if we just zoom into there, we can order some bread, milk, rice, and some pies, and submit them. And then you'll see that on the payment service over here, we'll get a payment successful. If we go down to our reporting service, we can just click to get the report, and it'll say we've had £1.20 per spent on bread, and some rice and some pies. And that happily works, so you can just keep ordering more bread and milk and pointless stuff. So then for every so often it'll fail because there's like a random number in there what says fail on this random number, and this time it's failed the payment, so this is nicely blown up in its face. Gave us some logs about it saying why it blew up. And then back in our shop, it's also said the following order was not processed, and it says 4 milks was not processed. Probably not able to see these very well. So it says 4 milk is not processed. And then if we go back to our reporting service down here, we can click that, and it'll just say we've had total orders requested is £5.70, but our accepted orders is £3.70. That's because we've not got a payment for that one. And that's pretty much it for that. So if I go back into the code to actually show you the code, which will probably be show you all this. Can everybody see that? It's a bit like crap, really. So we've got 2 messages in this app. We've got this I order accepted interface, which has a list of products, the one that I talked about before. And we have an I order requested as well, which comes from the shop. So after the payment's been accepted, we have an I order accepted, and when we've got one requested, order requested. And then we have 3 services down here. We have a shop, which is really simple. This is really hard to scroll around in a small window. So all it does is every single time we get a list of products, we just build them all up, and we publish this I order requested product, and it doesn't care what anything is happening behind the scene, it just keeps firing them off, and somebody else will deal with it. It also has this consumer here, which actually listens to faults. So this is when that message actually faults. So when the I order requested faults from somewhere in the system, it'll also listen to that and just tell us that it's blown up. So that's the one what we saw a minute ago. And then our payment service is pretty simple. All it is a I order consumer. It consumes that I order requested, and then just publishes. If it takes the payment, which is based on a random number, it then publishes the I order accepted, else it just throws an exception, so that's a simulating an exception. And then our report is pretty much the same thing. It listens to an I order accepted message, and then pretty much just goes and increments the counts in some mocked out data store, and the same thing for I order requested. And that's pretty much it. So that's kind of how that all fits together. It's really simple, and there's nothing really in the program startup except for actually just starting the bus instance up and telling it how to connect to Rabbit, and a lot of console garbage really. So that's just kind of to show you how easy it is to kind of like set that up, and to how it communicates and just magically just wires everything up for you. You don't really need to care about the underlying message broker and how that communicates. So, far away out. So there's lots of alternatives, obviously. The Zen Service Bus is one of the biggest ones, what people mostly know. So do you know Zen Service Bus, everybody? Yeah. But there's also Shuttle ESB, Brighter, Fubar Transportation, and Rebus, and Celery. I think Celery is more of a Python one as well. I think it's based on Python as well. So there's lots of other things out in the same kind of space. But I've used Rebus, N-Series Bus, and MassTransit, and I find MassTransit a lot more easy to get along with and easier to configure than a lot of the other ones. But that's really it. But thank you for listening. I hope you've learned something at least.
Quick question, sorry.
Yeah, questions?
I've not used like RabbitMQ. If I was just to try and use RabbitMQ by itself, is the benefit of using MassTransit that there aren't really .NET interfaces for RabbitMQ, or does it give you more?
No, so there's a client around RabbitMQ, the RabbitMQ client for .NET, but it gives you all the root and everything else around it and all the serialization. So if you wanted to just talk over Rabbit yourself, you'd have to say, go create me a queue, go create me the exchange, go bind that exchange to that queue, etc., and do lots of this like work to kind of build up your own kind of routing topology of how you want your messages to route. And then when you publish a message onto it, then you have to say, I want it to serialize in, then I want to put that serialized body into here, then put the right headers on and all the rest of the stuff. And it just kind of does all that for you.
So definitely worth using it.
Yeah.
Cool. Any more questions?
Questions?
Thank you very much.
Sorry, I was a little bit late. Rather than using RabbitMQ, could you use the Azure message queue or something like that instead underneath?
So with MassTransit, I've used RabbitMQ mostly. I've also used Azure Service Bus, and I've also used it using Azure Service Bus with Azure Functions as well. Yeah. But they're the three ones two really, what I've used. But I know it's underpinned by, you can use other ones as well, like ActiveMQ, and that's to support the kind of like SaaS platforms within AWS. Yeah. So ActiveMQ is like Amazon MQ. Amazon MQ is ActiveMQ anyway. And SQS is just the kind of the really simple message queue stuff for AWS.
It's quite powerful and you can use any kind of messages.
Pardon?
You can use any kind of like messaging system underneath it.
Yeah, well, it supports them. The three what I went. So there's whoop, there you go. Gone too far. Got to click happy. Yeah, so you use it's Rabbit Azure Service Bus. ActiveMQ and SQS, that's all the ones what they support. You can actually build your own as well, and they're quite easy to build if you understand how their pipelines work. So it's quite extensible as well. I've done quite a bit of work on MassTransit as well before. So I wrote the MongoDB integration for it, for all the sagas and data storage behind it, and also the encryption for the message encryption. So how it does message encryption over the wire for everything. So it's quite easy it's very extensible. So it's pretty easy to get along with.
Just a quick one. I'm guessing, or I'm assuming that when you subscribe to a message using a consumer, that creates a routing in the background. Yeah. And if that service goes offline, then that routing will still exist, so the messages will be queued up.
Yes, so by default it starts up and configures all the bindings and the queues for whatever you're subscribing to. Yeah. But you can also make it so if it goes offline or dies, you can make it auto delete them, and you can also when it restarts back up, you can also purge the queues as well and stuff like that. So if your service does go down and you have like a backlog of requests and you don't really care about them, you can just purge them all when it starts up as well. And that's just all configuration, and you don't really need to care about the broker underneath it. It just kind of works no matter what broker. Cool. Is that everything, everybody?
I think so. Thank you very much.
Cool.
That's the key. If you ever do anything live.
Yep.
Ready to go? Okay. Hey everyone, I'm Jamie. That's a picture of me, unfortunately. I do a .NET Core podcast. It is a .NET Core show. I do have some stickers if anybody wants any of these lovely, wonderful stickers. They are of the .NET Core bot that a friend of mine altered to make it look like it was my design, but there you go. So just really quick housekeeping-y stuff. These are some of the things that I do, and I left that intentional grammatical error there because I wanted to. So I do a whole bunch of different podcasts. Each one of those is a podcast or a networky thing of stuff that I do. But that's not what I'm here to talk about today. I'm going to be essentially borrowing loads of information from these sources to talk to you a little bit about .NET Core and how we got there from .NET Framework. So I currently work at a company called Audacia in Leeds. That's why I've put that there. I wrote a blog post for their blog all about this kind of stuff. There's loads of sources. Excuse me. All of these slides are Reveal.js, which is like a Node technology. So they're all on GitHub right now, so you can clone that repo, npm run, and it will start. And if you hit S, you get a horrible view like that with a bunch of stuff over here on the right hand side with my notes that I should really be reading, but I'm not. Let's get rid of that. I bet I'm going to break this now, so let's go back to here. So you don't have to make any notes, you don't have to worry about missing anything. You can pull these down from GitHub, and I'll send that link out later. So in the beginning, there was Java, and it wasn't great, and it isn't great, right? But it was the de facto enterprise language for cross-plat stuff. But it wasn't rad. There was also C++ and PHP, but we don't talk about PHP, Python, Ruby, and all that kind of stuff. And then NGWS came in. Does anybody remember NGWS? Anybody? No? Okay, NGWS was the original name for what became the .NET Framework. And that image may be familiar if you've ever seen similar images showing off the .NET Framework. It is essentially how ASP.NET and .NET Framework communicate with each other. I apologize for the low quality of the image. It's the only version of the image I was able to find from the year 2000. It was originally going to use XML for absolutely everything, for communicating across the services and doing all that kind of stuff. And reportedly, Steve Ballmer, the CEO of Microsoft at the time, hated NGWS as a name, which stood for Next Generation Web Services. Then along came the new name, which was .NET. Here's a quote I got from a Stack Overflow where somebody had asked, why is it called .NET? But essentially, there's a whole bunch of reasons, the chief one being that ISPs at the time, all of their top-level domains were .NET, so you could go to myisp.net. So the idea was to reinforce the idea that this was a network and internet-based technology. But there were other reasons, like COM 2.0 didn't really work, you couldn't really advertise it, and there's even stories of people walking around Microsoft with the different names planned on t-shirts, and you had to go up and vote and say, yeah, that's a great name for the new technology, and they collected all sorts of stuff. There's loads of different competing names as to why, reasons as to why it's called .NET. Then in February 2002, they announced Visual Studio.NET, and on stage they said, every platform, one language, which is almost, oh cool, I've screwed up the HTML in here. Fantastic, but that's fine. But essentially, every platform, one language, which competed with one language, every platform, which was Java's, one language, every, and it was, so, we'll skip over that. And then if we fast forward really quickly past 2002, so .NET Framework has come out, we go straight to 2016, .NET Framework's come out, it's gone through lots of different iterations, we're now at 4.6, I guess, and then they share this slide, Microsoft Heart Linux. During that time, between 2002 to 2016, Microsoft had gone and bought Mono and Xamarin, and Mono, if you don't know, was originally planned as a white box re-implementation of .NET, so they went and bought that. .NET Framework 4 becomes 8 years old. Ballmer leaves, Satya Nadella is promoted from the sort of web team up to CEO, and he brings all these ideas of we need to move to the web, we need to make Azure a proper platform, because Azure has been around since about 2000, people have been playing with it since then, and he said we need to go all in because everybody's going to want to do Azure stuff, everybody's going to want to offload everything to the cloud. And then they start offering Linux VMs because they're like, well, we want people to run apps on Linux, and everybody went, but we can't do .NET on Linux. And if we take a step back to September 2nd, 2014, during a live stand-up that Hanselman, Hunter, Edwards, and two other people that I can't remember the name of, that I feel really bad now, this happened. So essentially the most important bit from this image is Scott Hunter saying, that's my goal. I want you to be able to host ASP.NET apps on Linux as easy as you can on Windows. I do have this little grey box down the bottom. There's a player to play the actual quote, but I can't be bothered. And you won't hear it because my laptop is on mute. So yeah, .NET apps on Linux servers was the reason why .NET Core became a thing, because Mono has its own little life cycle, and it has Mono supports things that .NET doesn't, and .NET supports things that Mono doesn't. So we got into that weird situation where you couldn't just target Mono and it just works on Linux or Unix or wherever. So yeah, so we already have .NET on Linux, right, with Mono? No, well we do, but we don't. Because Mono, like I say, targets different things and does different stuff. In fact, there's an episode of my podcast where I talk about how Mono actually has supplied features that .NET Framework was going to supply a whole 2 years before .NET Framework supported it. So it has its own release cadence and its own speed that it releases stuff. So we've got Linux VMs on Azure. Docker has now become a thing. Mono already exists, but we've got problems with that. So .NET Core is essentially a cross-platform, well, was originally designed as a cross-plat re-implementation of the .NET Standard. I'll come on to what that means in a minute. Whereas Mono is a cross-plat .NET Framework with stuff added on. Like I said, the stuff that Mono adds that .NET Framework doesn't. And Mono, since it's built in C++ from the ground up, whereas .NET Core is built in kind of in C# and put through the Roslyn compiler to then compile down to C++, you end up with smaller binaries for Mono, but more features in Mono that you don't get in Core. It's all a bit weird. But what's .NET Standard, right? We've already got .NET Framework, .NET Core, Mono, Xamarin. I've already mentioned a whole bunch of stuff, right? It's all getting a bit confusing. So the idea with .NET Standard, I'll come on to what exactly it is. Is literally a standard document. Presumably you've all got bank cards, debit cards, credit cards. These adhere to a standard that the international banking community has agreed to. Doors, they're all a specific size because the door manufacturing community, I don't know, have decided what size a door should be. I had a mini rant earlier on about universal serial bus being a universal thing because there is a standard that says certain power lines will be used for certain things. So essentially we end up with this really blurry image, which I apologise. It's really clear on my screen, but then it's my screen. So .NET Standard is essentially a standards document for .NET. It says in .NET Standard 1 you can expect to have this API and this type and these things. So you can see here, props to Emo Landworth for putting this together. There's a .NET Standard version along the top, going from 1.1 all the way up to 2.1. I took this screenshot like 2-3 days ago, so it's still pretty much up to date. And then there's all of the different .NET platforms down here. You can see there's quite a few. And each one, there is a version number that, so like 1.0 of .NET Core supports 1.0 of .NET Standard, if that makes sense. So if you target .NET Standard 1.0, you're going to be able to have all of your code run on all of these platforms. The further up the tree you go, the fewer platforms you can support, and then you have to target higher versions and stuff. That's just because different APIs are involved in different places. It's a really, really, really complex way of describing what Rocky Locker said on .NET Rocks today, which is what you do is you target the standard rather than a specific platform implementation, rather than framework, rather than core, rather than Mono, rather than Xamarin, UWP, Unity, all of that stuff. You target standard because pretty soon we're going to have 4, 5, 6, 7, 8, 9, 10 platforms to support. Because the idea is that because the standard exists, you can write a .NET platform that implements that standard yourself. And then people can release apps on that, but using Microsoft's build tools and the open source stuff. So yeah, target standard, and that means your code is guaranteed to work on .NET Core, on .NET Framework, on Mono, on Xamarin, on UWP, Unity, all of that stuff. And there are full steps on today's .NET Rocks on how to do that. So I'd recommend having a listen to that if you get a chance. But what is the .NET Standard? Think of it like an interface, right? So like I said, .NET Standard 1 provides you with certain things. So we can see here, .NET Standard 1 provides us with system collections, and all of these things, and loads more. Whereas .NET Standard 1.1, look at that, it scrolls magic. 1.1 implements 1.0 and adds these things. And I'm showing an example here of .NET Framework 4.5 implements .NET Standard 1, and it has all of the stuff. It's a really badly put together example, I apologise, but this is the way that I understand it. It's a set of interfaces, and the platform sort of implements those interfaces. So you know that .NET Framework 4.6.1 supports .NET Standard 2.0, but none of these really mean anything, really, if you think about it. But they do. So Framework and Core have a completely different cadence to them. .NET Framework is intrinsically tied to the Windows kernel. They can't ship an update for Windows for .NET Framework without also updating the kernel. So there's no way that it's going away at any point. Yeah, I didn't put the link there. But yeah, .NET Framework is not going away at any point soon. Best guess is maybe 2-3 decades before it goes away, because it would require a complete rebuild of the Windows kernel to be able to do that. So they're not going to get rid of it at all. .NET Core has been around for around 2.5 years, and we're already at version 2.2. As we said earlier on, we've got version 3 preview 2 out soon. So the cadence for that is really fast. A lot faster than .NET Framework, because .NET Framework is so tied in with the kernel, right? And yeah, .NET Framework is not going away at all, which is one of the things, let me go back one of the things that comes up a lot, unfortunately, during one of the early episodes of my podcast. One of the people I had on said something along the lines of .NET Framework support is going to sort of silently drop off over the next few years, and that was a complete misunderstanding, complete misquote. There was a Medium article where somebody said .NET Framework is dead, and even Scott Hunter jumped in and went, no it's not, stop spreading lies. And he keeps having to bring it up at different conferences. .NET Framework is not going away because it's so tied in with Windows, so you don't have to worry about that at all. So you can continue to release for .NET Framework. That's not a problem. If you want the brand new hotness, you can go with .NET Core, and it's faster, it's cross-platform, and it does all of these wonderful things. It will have more features eventually than .NET Framework. So at the minute, .NET Core has span of T, whereas .NET Framework may not get that. We don't know yet, because to get that, they would need to release an update, and every single person on the planet would need to install the new version of Windows to get that. So we can't guarantee that these new features are going to be there. That's pretty much it, I think. Here are some of the sources I used for this. All of those are clickable links. Like I say, if you pull down the repo, do npm start after installing, it will start this up. These two, so the history of .NET with Richard Campbell on both of those two are wonderful little wonderful talks that he gives about the history of how we got from Microsoft starting in the 70s to 2017, 2018, depending on when he gave the talk. This is the community stand-up where they mentioned ASP.NET on Linux servers. This is the first episode of my podcast. These are 2 blog posts I wrote about it. Interestingly enough, whilst I was planning this out, 2 weeks ago I released an episode where I interviewed Richard Campbell about the history of .NET. So if you haven't listened to that, head over to .NETcore.show, because that is, I remember recording it and I was just sat there like, because I couldn't believe that I was talking to Richard Campbell, right? And then my friend James from The Cynical Developer texts me yesterday and goes, hey, I'm having a drink with Carl at the pub in London. Oh well, next year I'll be at NDC, hopefully. That's it. That's all I've really got. I've got loads of I can go into more information if you need. I do have the stickers if anybody wants one. Any questions on that? That was really quick.
Why do you think that they've stopped rolling updates for .NET Standard or .NET Framework, considering they have been doing for the last 10-15 years?
So
you cited the reason of you have to roll it out to everyone, but then that's what they've had to do the whole time anyway.
That's true, yeah. So the question was, why, in my opinion, why have they sort of slowed down the release cadence of Framework? And I think there is a big team of Framework developers at Microsoft, and they're all supporting Framework and stuff. But like I say, it has to be tied in with the releases of Windows. So you can't just go, hey, here's a new update for Framework, because no one's going to get it, because it needs to go in with the Windows update stuff. And they have been doing that, but and I hate to say it, how many Windows updates recently have been broken? In October they released one that wiped out your documents folder. well, it didn't. It made it look like it did, but you know what I mean. So they have to quality check absolutely everything, because we've got 20 years of apps that are using APIs that were created in .NET Framework 1, and we're kind of, maybe we shouldn't have had array list of type T, I don't know, but you know, we have all these APIs now that they have to support, because if they release an update and something's broken in one of them, then that's 20 years of app development down the toilet. So it's becoming harder, I guess, requires more time to sort of QA everything and try out, well, if I have an app that uses array list of type T and it's an ASP.NET app and it uses Web API and it uses this and uses that. So I can only imagine that their unit test suite must be massive, and it must take days, maybe weeks to run. At which point, you know, I mean, they've been releasing 3, 4, 5 previews in the past year of 4.8, and they keep releasing it, then rolling it back because somebody notices there's a slight issue here or there's a slight issue there. You also have to remember that it's closed source, in that not in the same way that, so .NET Core is completely open source. You can go to GitHub and put a pull request in and I don't feel confident enough doing it, but you could put a pull request in and make a change. If you do that, you get a little package from the .NET Foundation, which is fantastic. But the problem is that .NET Framework is closed source in that you can't commit to it, but you can read the source code. So then it's like it's a Microsoft only enterprise technology that only they can contribute to. So they don't have that sort of, they can't have the high cadence of .NET Core because they don't have people working on it 24 hours a day like they do with the open source stuff. But they have that for .NET Core, but not for .NET Framework. So I think it's more of an engineering power thing, and being able to QA it and run it. They have to be really careful, because if they release an update that breaks everything, that's, you know, all of these enterprise apps are then kaput. You know, so maybe that's it. That's what I think anyway. That was a really long way of putting my opinion across. I do apologise. I need to get better at that.
They did say that they weren't going to release some of the major versions, so there's not going to be a .NET version 5. It's only going to be 4.x.
Yeah, the current plan is to. How do I put it? The current plan is 4.8 is the last major release. There'll be security updates and support updates, but that's the last time that they're adding features, like new features to the .NET Framework.
And they said the last article what they published, they said the next release cycle is in a year for it.
Yeah.
So it's pretty much dead, really. You know?
Dead in
or
the.
done.
Yeah, well, yeah, that's it, right? It's more feature complete than
Yeah.
dead, I guess. You know, they've got to the point where they've added all the things that they want and added all the things that they can, and they're going to continue to support it. I mean, you have to think like VB6. It was in that Rocky Lotka episode. They talk about how VB6. The last update to VB6 was 20 years ago, but they still ship it as part of Windows. So you install a fresh version of Windows 10, you've got the VB6 runtime, and they still support that.
VB6 app will still run.
Sorry?
I'm going to dig out my discs and then get a floppy disk drive from somewhere.
Yeah, exactly. Right? Exactly.
So yeah, I was just going to say that .NET Framework is going to be around for tens of years. Like I said, it's not going to be necessarily updated and actively worked on, but there are systems out there running on mainframes and kernels still. So if .NET Framework is going nowhere, you might not do greenfield with it, but it's still going to be around. So.
Yeah, that's exactly it. So the short version is .NET Framework isn't going anywhere. If you target .NET Standard, then your class libraries will still work with .NET Framework, so long as you target the right .NET Standard level. But then you can also have that same code run with .NET Core, in the same way that .NET Core 3.0 allows you to do WinForms on Windows, kind of on Linux. There's a hacky way of getting it going, like I said earlier on. But you need to sort of, it allows you to target these things, and you can then just move your code. You can create a completely different UI for Mac or a completely different UI for UWP, but use the same code underneath that you wrote 15 years ago. And that's the beauty of this. That's where this beautiful thing comes from. Any other questions? Oh, yep.
So I guess I'm thinking about where I work at home. We've got loads of legacy .NET frameworks. Is it a case of there's no need to convert that to core, just target standard, and you're good for 20 years?
I guess the question is, do you absolutely positively have to run it on a Linux server?
No.
If not, then keep targeting framework, I guess. Because there is a considerable effort to convert from framework to core, because core does things that framework doesn't, and framework does things that core doesn't. In the same way that framework and mono have different things going on with them, because core is going to have more things, and framework's going to sort of like stop positive development because there'll be no new features added. So if you can take all of your business logic and your services and stuff and target .NET Standard if you wanted to, and then you can swap out that sort of, if you've separated all your concerns and you have your front end and then maybe services, database access, logging, all that kind of stuff further down, swap all of these for .NET Standard, so just literally go into the CS project, put .NET Standard 1, swap out the front end, you've got it on .NET Core. But you don't have to do that. That's the thing, you don't have to at all. You can if you want, and you can invest the engineering time to do that, but why bother? It works, right?
Yeah, it does.
And it will continue to work for at least the next 10, 15 years. So that can be a future you problem, right? Exactly, right? It could be the next person's problem, not a problem. Oh, two more questions, yeah?
Like in the long run, will be anything that .NET Framework has that core will never have, or like a reason to start a new project now in Framework, sort of thing, or maybe a few years in the future if they're going to continue to maintain it. Sort of thing.
So I think it'll be large. Again, I'm not MVP. I don't know all the insider secrets, but I feel like it will be the other way around. So, like I say, core will have more things. The framework doesn't. And like I say, as long as you target standard for your sort of, I don't want to say core library, but your sort of your business services, your business logic, all that kind of stuff. As long as you target standard for that, then you can use whatever front end you want. You could continue to use framework. You can swap it out for core, UWP. You can even do it in Unity if you wanted. You could create like a game engine that talks to your service. Why not? Yep.
When you target anything for the standard, say version 1.0 or something, do we need to install any packages at runtime, or still it runs on the framework itself?
So yeah, so the question there is, if you target standard, you need to include the runtime, and you don't. So the idea is that standard provides you with, it guarantees. If I go back, I bet I've gone past it, haven't I? Yeah, I've gone way past it. Back this way, wherever it is. There it is. It's really blurry, and I do apologize. Maybe I can zoom in. Let's see what happens. Here's a web app. Can I zoom in? Nope. It's not going to let me zoom in. Okay, fair enough. If I knew how to zoom in, then actually, if I come out of, nope, okay. If I could be bothered, I could bring up the image on my computer and zoom in. But essentially, this is literally, the standard versions are literally just, you will get these APIs regardless of, and base types, regardless of which runtime you target. So you, on .NET Core, you will get array of, you'll have list of type T. And on .NET Framework, you will also have list of type T. The underlying code on Framework and Core to implement those things may be different, but you will have those same APIs. The list of type T will have add, it will have add range, it will have remove, it will have sort, it will have all the same methods and types that you expect. It's just that when you plug it into those different frameworks and runtimes, it will just run. That's the idea.
Doesn't mean .NET standard is not something like a runtime framework or anything, it doesn't have anything like that.
Yeah, it's not, like I say, it's not a framework or anything. So if I go back to here, you can literally just think of it as a, so this is interface INET standard 1.0, contains, it needs to contain at least these, so system collections generic, IO, link, that kind of thing. These are actual things that .NET standard 1.0 supplies. Because it's an interface, it doesn't apply you the code which actually does those things. It's .NET Framework 4.6.5 has the implementations of those things. So you can say, in the same way that if you have an interface for your service, you can go, my service dot add thing. It won't do anything unless you give it a concrete implementation of that interface.
Yeah.
So it's much the same thing, except that your concrete implementation is the framework, or is the runtime, or is the core.
Assume in that case, like say I write my core library, which is targeting the .NET standard 1.0, then I use the NGWS package to download some package. So what happens that package will be the .NET core or is it targeting the .NET framework?
So there's a statistic, something like 86% of NuGet packages, or some really high number, like 86, 72, some random arbitrary high number of NuGet packages work with .NET Standard. So you don't have to do anything. You can just literally pull the package down and it will work on your, in your
There's
app.
a few things they got support with both .NET core as well as the .NET framework as well. So in that case, which one it actually uses for the standard?
Yeah, you can use them with standard because most NuGet packages are just literally the class libraries and that kind of thing. They're not actually most NuGet packages don't contain the runtime. They don't contain any code to actually start the application. They are literally just a class and a bunch of supporting helper methods and stuff. So you can literally pull a NuGet package into almost any .NET standard app and it will just work. So that's the beauty of it, right? Microsoft, who would have thought, right? 2019, Microsoft, it just works. They've never been able to do that, right? Yeah? I'll just go back to here. Any other? No? Okay, cool. So thank you for letting me ramble at you. I'm at .NET Core Show on Twitter. .NET Core Podcast is a thing. I'll happily answer any more questions on Twitter or put you in contact with someone that I think can answer the question on Twitter. Or if you end up
Cool. Okay, everyone, welcome to the second half of Lead Sharp. Richard's going to be talking from now, Richard Tasker. In fact, Richard came to the first ever Lead Sharp and was one of about the 3 people who turned up. So he's been with us for quite a long time, and he did his first ever talk with us, and he's been getting gradually better and better at talking.
Well, we'll find out, won't we?
We'll find out. So, without further ado, Richard, please take it away.
Okay, thank you very much. So, thanks for Kev and Jamie. There have been some good talks. Thank you. So this is me, Rich Tasker. I'm pretty much everywhere online as RI Tasker. Any questions, email me. Email address is there. And occasionally I blog. Tonight going to be talking about ASP.NET Core routing and Carter and how we're going to build HTTP APIs. It's kind of been a long time since I've done a talk, so it's mainly due to these 2 people that have taken up a lot of my time, but hopefully kind of getting into the flow of things again this year. So, like I say, routing and Carter. So Carter is a library built on top of ASP.NET Core routing that kind of gives us a lot of the functionality that you would get with MVC or other frameworks. Generally, when I come up with a topic, I come up with the topic, but then come up with a cooler title later. So, in a slight change of scheduling, we're doing lightweight HTTP APIs with Carter. So, with further ado, so endpoint routing. This is the new way of routing as of ASP.NET 2.2. This is kind of built into MVC now. So if you've spun up a new ASP.NET Core 2.2 MVC project, this is what's happening. We'll go into a bit of detail about that in a bit. But essentially, it's in preview for you can get access to some of the APIs if you've got the preview version of ASP.NET Core 3. So we're going to build I'm going to show you an API I've built because 15 minutes. Using the APIs we get with endpoint routing. Then we're going to have a look at the same API but using Carter. Okay, so historically in MVC, what happens when a request comes in, you'll have your URL. That URL will then get matched to a controller, an action, or a file or something. This has happened quite late on in the request pipeline. So things like authentication doesn't know what is actually going to handle this request in the end. So with endpoint routing, this is this URL matching to a request handler, a controller action. It's happening at the beginning of this pipeline, this request pipeline, which is great because now like things like authentication can determine where this is going to handle, this request is going to be handled. So we can deny you access if it's like to the admin controller or something, or even like cross-origin resource sharing. So those sort of policies can be applied, and this is happening earlier on in the pipeline. These are some of the endpoints, the methods that we get access to. So on the right hand side,
We've got things like mapping a route to a controller, health checks. We've got Razor pages now, so we've got methods for that. As we are interested in APIs, HTTP APIs, we've got methods related to the HTTP verbs. So let's have a look at our API. Okay, what's that like at the back? Bit bigger. It doesn't go bigger. Okay, so hopefully it won't be too bad. But this is just a startup class. So empty ASP.NET web project with a startup class, and we are adding in our all our dependencies with the add routing extension. Now we're coming down, telling our application to actually use routing, and then now we're defining our endpoints. So here we've got our widgets endpoint. I haven't been very inventive with my sample application. We have a widget. It has an ID and a description. Setu. So here we've got we're mapping our GET request to this widgets endpoint. Essentially, because we are only using the routing libraries, we don't get any kind of additional like serialization that you'd get. So we're having to use like JSON.NET here to serialize our object and write it directly to the response stream. Coming down here, we've got our widgets by ID. And if you know a bit about like the templates, the routing templates, you can see here that ID is an integer. But what we're having to do here is actually pull it out of the root, and then it gets converted to a string, and then we have to parse it back into an integer. And then we can go away, select our widget, and then again serialize that out manually. Coming into our post. This time we're going to have to look at our request body, and that's a stream. So we go read that in as a stream reader, out as a string here, and then again deserialize that into our widget. Because we don't get any like validation in this, we're going to have to do our own kind of hand-rolled validation. So here, we're checking that the description isn't null or empty, and then if it is, return our unprocessable entity and a reason why. And then we've got a delete request down here again, which is nothing new that we've seen. Okay, so Carter. So as I was saying earlier, this isn't what I'm trying to come across here is that this isn't a way of doing things. I'm just kind of introducing you to another tool in your toolbox. So this is Carter. This is the GitHub page for Carter. If you've used Nancy in the past, this is almost identical to NancyFX. But again, Nancy kind of uses the Owen middleware. That doesn't really exist in .NET Core land anymore. So now we've kind of ported it, or not ported it, but put it on top of the ASP.NET Core routing, as I mentioned. But here we get some of the niceties of a full framework. So here we've got model binding and validation using Fluent validation. I can. Better? A bit more. We've got request hooks, before and after hooks, and we get a bunch of other things like content negotiation straight out of the box. Again, if you've used NancyFX, you probably recognize some of this syntax. so let's go back to our app. Okay, so this is our module. So all our routes are defined in the constructor of the module. We've got on this top line, we've got our widgets endpoint again. So there's the get request coming in. Now we've got this negotiate method. So if in your accept header, if you define application JSON, application XML, with very little configuration, this which returns it as requested, really. And it's handling the serialization. So I'm just passing this, read-only list down into our negotiate method, and it just returns it as requested. Again, with our route earlier, with our integer, we've got the list of route data, and now we're just pulling that ID out straight as an integer. Coming into the post request, we've got bind and validate. So here we're using, as I said earlier, fluent validation. That one. So if you've used that before, like fluent validation before, this is probably nothing new. So we've got our abstract validator, and we're just checking that our description isn't empty. So we can come out, check if our model is valid, and then carry on processing the request. Otherwise, return our 422, and here we actually get a list of formatted errors. So let's actually go see this in action. And one thing that I haven't really covered, so it's possible to actually configure this for OpenAPI and Swagger. So if you like that, you can use it. I've used it because it's really good for demo purposes. So here we go. We've got the Swagger UI, new .NET Core version. So coming in, try this out. As this is all in memory, we've got nothing in our database. So you can come in, let's create a widget. So if we just submit this now, we can see the validation. So we've got which property is invalid and why. And go. Excellent. So we've got our representation of what we've just created and our location. We can use that ID in this one, and we can actually get our final object back. Okay, so that is a very brief overview of Carter. Let's go back to some slides. Okay, so as I was saying earlier, a lot of APIs that I've worked with have been using like Web API, MVC sort of thing, and it provides a lot of features. If you wanted to build, if you're kind of going down that really lightweight microservice route, big framework might not be the ideal thing, but this is an alternative. We've had a quick look at some of the stuff that's powering Carter. Admittedly, this is kind of still in development at the moment, as it's all in preview. So we looked at endpoint routing. had a look at an API just using endpoint routing, and then again kind of finishing off, just showing off some of the features available in Carter. So code and slides is available on GitHub. I've got a nice little, I thought this is a little bit of an experiment. So if you've got a QR code scanner, please scan it. And again, you know, if you want to contact me, tweet me, whatever, details are at the bottom. But thank you.
I was going to say questions, so if there are questions, you may get 2 sets of claps.
No problem. Come on, Joe.
Is there a easy orthograph issue on GitHub right now that anybody in this room can contribute Carter straight away?
Yes, there is. What it is, I can't tell you right now. But I believe it's around
response negotiator.
Yeah.
There's a little issue with it, and it's a one-line bit. So if you've already got a laptop, I'll merge it right now.
But yes, you know, we are a very open community. Come on, we have a Slack channel. Please join the Slack channel. Links are on the GitHub page. Get involved.
As I said, is the main motivation for this, as opposed to sort of web API, people who want something really lightweight, and what sort of, where do you need something that lightweight? Where are you that bothered about the size of the framework?
It's a good question. It's very, I don't know. Go on.
So it's a different way of routing. So that's one of the benefits, but it's also significant for basically what they call MVC.
Okay.
Yes.
So it says speed is one of them.
Yeah. So if you think about the layers of abstraction that you get with MVC, we literally have like 1, 2 layers.
Yeah.
So it is literally hitting the .NET Core code earlier than it would in MVC. So.
No, that makes sense. I've never sort of thought, oh my god, this framework's so heavy, my machine can't possibly code
Well,
with it.
yeah,
but
exactly.
if you try and get high throughput or high speed, then I can see that. Logic.
For example, we've got an application which is a implementation and service bus, and our application can have plugins, and we needed to write a web service plugin for the end service bus, so sort of an endpoint as a web service. So we use NancyFX. If we had to use it, .NET Core, potentially this would be a perfect opportunity to use it.
Yeah. Because so is NancyFX not going core? Is NancyFX?
So there was a big push 2 years ago, 3 years ago, where it was ported over, and it was actually supported by a previous company of mine, and Joe's, where they actually funded it. So this, you know, private company funded the this migration over to .NET Core. As I said earlier, it sits on top of Owen, which is still a thing, but with the new implementation of middleware, it's kind of dwindling. Yeah. So, yeah, if you're considering like looking at Nancy, look at this.
Any more? Okay.
I wasn't going to say that,
Nancy's
but you know,
it sounds like.
I just might as well open it up. Okay, first thing going wrong. Hi guys, so how about some unit tests which you can actually, as has been suggested in one of the talks by Ian Cook, a very famous talk, very well-viewed talk, which you test the actual units, as in the business units, because you can test the whole pipeline, and this is, I'm talking about, sorry, my apologies, in relating to .NET Core, your middleware, your attributes, your controllers, everything, you can plug and play whatever and mock out stuff, and because you're using the whole pipeline, you can use the same unit test or tests to take over and put them in for your acceptance tests, your end-to-end tests, by putting in the actual services or databases in places of the mocked out stuff. So my name is Kiran Singh, and I'll show how light BDD, the small library, can allow you to do that in conjunction with .NET Core. And both the things are needed here. To my knowledge, it doesn't do any the other frameworks. So, without much ado, you'll just see this bit because we don't have too much time. So, a very small API which allows you to add and view some loans based on some conditions which I've concocted. So, the tests here would be, let me start with first pulling out your startup file, and you will see, can everybody watch this? So the first step in this, these tests are using these methods for triad scope. These basically allow you to instruct the framework to check whether if this is already given set up. If not, then it adds it, which is not so easy for which hasn't been done for the add DB context. So it goes through a bit of cycle which we can go in if we have time later. So that's the first thing which allows you to write these tests. And the usual structure where I've seen these tests being run are you have your source project and your tests, which include some acceptance tests run by your developers to where the dependencies or external services are mocked out, and then in a separate project or in the same project you have your actual acceptance tests which are exactly the same as the unit tests run by the developers, but the dependencies are there you provide the actual databases and services. In this case, I've just used one database, and I've used SQLite to allow me to do it without anything heavyweight. And when you run the tests, you get something like, I don't know whether this would be visible to everybody. Basically, your scenarios are run, and you get your whole feedback. And I'm running the same unit, same loan tests in this case, which are in the. Let me. Sorry. So let's focus. Let's focus on one test for in particular, which is slightly more complicated. So you have a valid customer ID and a valid loan ID coming in with all the other set values, but your loan manager has already exceeded the max customer amount of active customers allowed. So this would be your sort of test you will create with Light BDD. You can set up your label, your scenario name, your display name, which is displayed out when this is run, and your again another hook which is provided, scenario category. In this case, I'm setting it to validation. So and the general syntax follows the same the name as what you have set up over here as the display your description. Then I'm using auto fixture to create the variables, and your loan context is your implementation class which does all this stuff. So all these methods are part of loan context. So as you can see, all these are async, and you can run async steps or synchronous steps. In this case, this is actually the running with actual database. So mostly you've got async steps. If you see the same class in the mocked out loans test, or same test, my apologies, you will see that it has got one mostly synchronous and just the one asynchronous step when it calls the service. So just to going inside in one of in the first method, and since this is the unit test, you have your mocked out repositories returning your mocked out, with mocked out with setup methods, and this goes till So the first two are checking your whether your customer ID is returning true for your customer ID, customer being valid, and the loan manager being valid. And then the loan manager is being set up to validate, the loan manager class is being set up to validate that the loan manager has exceeded the number of maximum active customers, so it will return false. And then obviously the loan manager repository returns that loan manager. Now this bit comes to this is noticeable is that this whole thing is testing your execution of, I don't think I have it open, sorry, the fluent validation which is being done in your fluent validation class. This particular rule which is being set up, I'm not sure if everybody's familiar with fluent validation. It basically allows you to validate complex business rules and because we have added it in, I'll show you where it has been added in the startup class. This gets called before your method reaches your request reaches your controller. So all these methods, and just we won't have time to go into the ins and out, but what's happening here is your loan manager is being validated in your loan manager database because a method which calls the service, and then it has dependent rules where if the customer ID is valid, then it calls this method which basically checks that your loan manager is allowed to take your add loans for that particular customer. If the customer is already a part of one existing customer, then he can allow it. But since he's exceeded the maximum number of active customers, if it's a new customer, it will return false. So this is this is the method which has been mocked out in our test, or in the context to be more exact. So this is this method gets called and then basically sets up your stage for your test, and then when the request is received, which basically is a straightforward well, should have been straightforward, but here we are adding all the, so you're setting up the test server which calls our which is called when the request is posted by the client at the bottom, and here we are adding all the dependencies including our mocked out context and the other mocked out repositories and other services. So this makes sure that when the startup method is called, and since we are calling triad scoped or triad singletons or whatever methods, these methods won't be, so they won't look for the dependencies outside because they're already there. So that way you can carry these tests out without any internet connection even. So, and finally comes your method, sorry, again this way. So when the request is received, and then you are checking the response coming back, and you first verify that all the methods you have set up, they get called, and then you check the response status code, and the message returned in the response is the same as the error message you set up here, which is why you passed in the loan manager ID to be set up with in the previous method. So that's your mocked out unit test. And to very quickly I'll go over the actual test, which is, or the acceptance or integration test, which is done as I previously mentioned, which has got mostly async steps, and that's because they are calling actual databases. In this case it's just a SQLite database, so you'll see much more in the setup. First of all, I'm creating the loan request, and that loan request is being set up with the minimum values as I have arbitrarily decided that which are needed and which are validated by your Fluent validator. So if I don't set them up, the test will fail. And then I pass in the loan manager ID, for which I'll set up the conditions for it to fail, and which is basically this is a bit more of stuff needed for your SQLite database to be set up with your maximum active customers allowed, which I pick up from the loan configuration of that particular project, and set up the active customers, save them, and then set up the loans on the loan manager, so that with the values set, so the loans are active, and save the changes. So once this is set up, your next call will slightly smaller, because now you're not doing any setup, you're just calling the client, and the test server is calling the full startup method, but without any substitutions, and you return get the response back, and your you validate that it's all exact. This is for the invalid customer, my apologies. And you validate that your response returned with the bad request status code, and your error message is right. Plus, you're checking that the loans set up in the database, which was done in the previous method, which set up 10 loans, or 10 is the value I've used here, but whatever is the maximum number allowed loans, that you get that from the database to by calling the database, in this case SQLite database, and validate that they are all still the same value. Hold on, I've lost the So the loan count is exactly the same as you expect. So this the whole setup allows you to use the same tests which check your whatever your business rules are in language which your business can understand, and you can use you can unit test from without worrying about the implementation. Your loan context class or whatever context class can change fully. Your implementation could change fully. You could take out that validation from your Fluent validation to your and do it in your services or in your controller class. Your tests will remain the same. You just have to make changes to your loan context to set up, or put in the real services instead of the mock services, and you can still get the same result. Hopefully, more robust software. The primary or one of the advantages of this sort of thing is you can, if you want, you can skip your unit tests, which I haven't done in this project. Also, I'll give the code later. It's on Bitbucket, but you can, if you want, you can skip the actual unit tests and just rely on these tests. In fact, if any of you have seen the talk by Ian Cooper, he argues that this is what Ken Beck initially, who wrote the book on TDD, meant when you say unit test. You're supposed to test your business units and not your classes, and this allows you to write those tests from the business unit perspective, so your implementation can fully change, but your tests will remain the same, and you won't have to go and change hundreds of unit tests if you are, for example, ripping out some classes or ripping out some implementation and putting in some other test. Your final tests will remain the same. I think that brings to an end. There is, oops, I've forgotten the shortcut, sorry. Yeah, and just one more thing. Yeah, so in this case, as I've previously mentioned, that this method is what is again probably better. So since you don't have add DB context anything to try it out, so I'm using manually checking the services that is not already added and added in, and then setting up the DB context in this case. Again, it could be anywhere. You could put it on SQLite or actual SQL Server or your Azure SQL. It should all work the same. I think that's it from my side. Any questions from your side?
Thank you very much. So we rushed the beginning a little bit. I think it's worth saying that sort of Matt sort of does the majority of the work here, and Matt sort of wasn't feeling very well and still dragged himself in to help us start up, and has had to go. And him not being seen is the reason why we just had water, because suddenly I became in charge and I've done a terrible job, so I apologise for that. So one of our sponsors is Tronic, which is Matt's company. They do e-commerce stuff, so please check them out. Another one of our sponsors is Fruition, guys here, and they did a fabulous job of finding me a job when I desperately needed to earn a teeny bit more money, so they're definitely worth talking to, and I think you'll be at the pub later. Yeah, they'll be at the pub. Future Labs, the people who sort of give us this space, so big thanks to them. Stackify and who are Conflux? Skeleton. Oh, they do book publishing stuff with Stackify is a great little sort of error reporting tool. PostSharp also does some things. You can tell I'm not normally I've been in charge for a little while. So some people, I can't make the pub, so who wants to be in charge of going to the pub? This guy at the back has volunteered. Richard Tasker, and we'll take you to the pub. So we want to follow him, go to the pub and have a drink. That's kind of one of the nice things about this. Thank you all for coming. And quickly, next month is a talk by the guy, lead developer at Manchester Airport. I forgot what he's talking about though. I think it's about logging. Do you have a better title for us?